hope we pray for better days.
What is going on, guys? Welcome to this tutorial series on algorithms and data structures. A lot of you guys have been waiting for this, and it's now here. One of the most highly requested projects on Neural 9. People on Instagram, people on YouTube have always been asking me when I'm going to release some more content on algorithms and data structures. I've made some infographics, I've made some stories on Instagram about algorithms and data structures, but I've never made a real course, a real book, a real piece of content that gives you a structured introduction into algorithms and data structures. And now it's here, I'm doing it, and this is because a couple of weeks ago I finished my computer science class on algorithms and data structures in college, and now I'm going to teach you what I learned in this class and what I know about algorithms and data structures in my way that you already know from the Python tutorials, in a very simple way, in a very intuitive way, but still in a very educational way. So you're going to learn a lot here. And this episode today, the first episode, is the introduction episode. So today we're going to talk about what you can expect from the series, what are the topics that we're going to talk about, what is the structure of this tutorial series, what are we going to learn, what are we not going to learn, what is the style of this series, and that's basically the content of today's video, so let us get right into it. So let's talk a little bit about algorithms and data structures and about this tutorial series. And the first question we're going to cover is why you should care learning about this. Why should you learn about algorithms and data structures? Why is this important? And I'm going to give you a very straightforward reason, a very good reason to learn these things, even if you're not interested in them. And this is because most interesting companies, most tech companies that you want to work for are going to give you questions or problems based on algorithms and data structures in job interviews. So whenever you apply for Google, whenever you apply for Facebook, whenever you apply for any big tech corporation, Microsoft, they're going to give you a question in your job interview. And this question is most likely to be based on or will most likely be based on algorithms and data structures. So this is a very practical reason to learn it, but I'm also going to give you a bunch of reasons why it's important in general. Now, it doesn't matter in which field, in which subfield you want to go. If you want to be an ethical hacker, if you want to be a cybersecurity expert, if you want to be a computer networking expert, if you want to be a programmer, machine learning engineer, whatever you want to be in computer science, you will need algorithms and data structures, and you will definitely benefit of the knowledge here. In ethical hacking, in computer networking, in computer security, you're going to need to understand hashing and encryption and algorithm and runtime complexity of brute force and dictionary attacks and all that. You're going to need to have a basic understanding, a fundamental understanding of what an algorithm is, what runtime complexity is, what different data structures are, just because you're going to encounter them all over in the field of computer science. And it's the same, of course, for programmers. Whenever you're working on an application, you will have real life problems to solve, and these problems are actual problems, right? And you need to solve them with algorithms, and you can make up these algorithms from your head, but then you don't know, is this algorithm efficient? Is it not efficient? What's the runtime complexity? Is this something that can scale? Is this something that will break every computer or will take forever if I run this? So you will need to understand at least the basics of algorithms and data structures to be a good programmer, because everyone can write code that solves the problem, but not everyone can write intelligent code. And just knowing a programming language, everyone can learn a programming language. A programming language is just a tool. If you know Python, Java, C++, that's a tool for implementing algorithms, for solving problems. And if you're a programmer, you're not someone who knows a language. You are someone who has to solve problems, and you don't solve problems with Python, you solve them with algorithms that you implement in Python, for example. So this is why you need to learn about algorithms and data structures. It's one of the most fundamental fields, and it's needed everywhere. No matter where you go in computer science, you will need algorithms and data structures. Now, I hope I was able to convince you that it's a good idea to learn about algorithms and data structures, so let us get to the second point, which is the topics and the structure of the series. What can you expect from this tutorial series? And when it comes to structure, I really value flexibility in this particular case, because I'm not interested in designing a curriculum or a schedule that tells you first episode is this, second episode is this, third episode is this, and so on. I'm more interested in having a basic idea of how I'm going to structure the content. So I know first we're going to do the basics, what are algorithms, what are data structures, runtime complexity, and so on, then the basic data structures and so on. We're not going to start with P&P problems if you don't know anything about algorithms in general. But we're going to keep it flexible. So I'm not going to have a static structure that has to be followed no matter what. We're going to start with some basics. We're going to talk about some data structures, but if I think in the middle of the series, hey, I want to add this topic as well, I'm just going to add it without caring too much about the static structure that I have in my head. So this is just one thing that you should know. It's going to be very flexible, and the topics are going to be mainly about algorithms in general at first, runtime complexity, how to calculate them, or how to calculate it, different data structures, lists, linked lists, binary trees, and so on. We're going to cover all the data structures that are important. We're going to cover all the algorithmic complexities that are important. We're going to make a lot of, or talk a lot about examples of algorithms like sorting, searching, minimal spanning tree. We're going to talk a little bit about graph theory as well. And this is basically what we're going to do. Later on, depending on how the series goes and how much you like it, we're also going to go into more advanced topics like dynamic programming or NP problems, NP complete problems, and so on. If this series is liked by you, if you like it, I'm going to make more content, more advanced content. If you say, no, it's not that interesting, if it doesn't get a lot of views and a lot of likes from you, we're going to stop at the intermediate stage. So we're going to cover the data structures, the algorithms, the complexity, and so on. If you like it, again, we're going to go into more advanced topics as well. So this is the structure of this series, very flexible, and depending on your feedback, we're going to do more content, more complicated content, more advanced content, and if you don't like it, we're going to keep it at the basics. Now, one more thing that you should know about this tutorial series is that it's going to be more focused on explaining things simply and intuitively instead of focusing too much on rigorous scientific definitions. So we're not going to define everything scientifically accurate, which does not mean that we're going to define it in a wrong way or only scratch the surface. We're going to go deep into algorithms, but not everything needs to be defined in a mathematical, scientifically accurate way. So we're going to focus more on you understanding the concepts of linear time, of logarithmic time, of binary trees, and so on, instead of always writing down the textbook definition of a binary tree, the textbook definition of this and that. Sometimes we're going to do it when I think it's useful, when I think it's necessary. We're going to also cover scientific, mathematical definitions, but for the most part, we're going to focus on intuitive explanations of how things work and not always going to confuse you with mathematical jibber jabber or any nonsense. It's actually not nonsense, but I'm not going to make it extra complicated for you. I'm going to explain it simply, and maybe we're going to add some scientific definitions afterwards so that you're not getting confused, because I know from my own experience that oftentimes when you learn about algorithmic complexity, it's very confusing what the individual things mean. So I'm going to try to confuse you as little as possible, but at the same time give you as much knowledge and scientific accuracy as possible. So we're going to try to find the perfect balance here. Now, a lot of you guys will probably be asking right now, what are the prerequisites for this series? What do I need to already know? What skills do I already need to have before starting with this tutorial series? And yes, there are prerequisites, but they're not too big. So what you need is a basic high school level understanding of math. You don't need complex calculus. You don't need complex algebra, probability theory, or anything like that. You just should have a basic understanding of high school level math. So knowing what the logarithm is, knowing what exponential growth is, knowing what functions are, maybe knowing what derivatives are, how to take the derivative. I don't know if we're going to need that for sure, but you should just have a basic understanding of how to deal with numbers and basic high school level algebra, essentially. This is one thing. And the second thing is you should have some basic coding skills. They don't need to be in Python, Java, or any specific language, but you should know your way around loops. You should know what conditions are, if-else statements. You should know what functions are. You don't need to know any advanced object-oriented programming or machine learning stuff, just basics of programming so that you can understand pseudocode. We're going to talk about pseudocode in this tutorial series separately, but you should know basic programming concepts, loops, if statements, functions, return values, all of that, so that you can follow along with pseudocode. These are the two things: high school level maths and basic coding skills. Now, last but not least, for today's video, I'm going to announce the book or the book series on algorithms and data structures. Right now, if you're watching this as one of the first viewers, you're probably not going to be able to buy it because it's not released yet. I have started working on it, but it's still, the work is still in progress, so it's not online, it's not available. But once it's available, you will be able to find it at neural9.com/books, where you can also find other books I've written in the past. And if you want to take it seriously, you don't need to buy this book, but if you want to take it seriously, you can buy this book to supplement this tutorial series with the perfect literature for this tutorial series. So if you want to take it seriously and you want to spend some money, you can go and buy the book on Amazon. Once it's out there, you'll find it, as I said, on neural9.com/books. And there you will be able to follow along in a structured way. So this tutorial series, as I said, is going to be more flexible. The book is going to be rigorously structured from A to Z. So you're going to have a perfect structure on how to learn algorithms and data structures. And it's going to be the perfect book to supplement this tutorial series if you want to do it. As I said, you don't need to, but if you want to take it seriously, you might consider this. Also, at this link, you're going to find the Python Bible series. So if you want to catch up on some Python skills, if you want to learn Python programming, you can check out neural9.com/books and buy the Python Bible series there to learn Python from scratch. It goes from beginner, intermediate, data science, machine learning, finance, neural networks, and computer vision are the 7 topics covered in the Python Bible series. So if you want to catch up on some Python skills, you can check out neural9.com/books as well. Because in this tutorial series, even though it's focused on theory and algorithms, we will do some code probably to show you some practical coding examples, some algorithms in action in real life, or not real life, but in real code. At least we're going to see how algorithms work, and maybe we'll choose Python. Probably we're going to choose Python as a language for that. So if you want to catch up on some Python skills, check out neural9.com/books. So that's it for the introduction episode on algorithms and data structures. I hope you're as excited to watch this series as I am to film it. And I hope to see you in the future episodes as well. If you like this video and if you want to see more videos, more episodes of this series, make sure you hit the like button. Also, make sure you subscribe, and also make sure you leave some comments in the comment section down below. Feedback, questions, whatever it is. First of all, I can answer you, and I always answer YouTube comments. Second of all, it pushes this video, and the more you push this video, the more content you'll get for free on YouTube. So make sure you leave some feedback or make some wishes or ask some questions or just write down, great video, I loved it, I want to see more. Whatever it is, leave some comments, hit the like button, subscribe to this channel, and see you in the next video. Thanks for watching. Bye.